Welcome to video 4.5. This one will graph tangents and cotangents, secants and cosecants. And it all goes back to the unit circle, and then we're going to put it on the linear graph. We're going to start first with tangent. I need you to remember that tangent is sine over cosine. Let's go back to our unit circle. If sine is over cosine, that means tangent is undefined where cosine is 0. Well, that happens here at pi over 2 and 3 pi over 2. So it's undefined at those values, meaning it cannot exist there, meaning you have an asymptote at all the pi over 2's. So we can go and draw those in. It cannot exist at those values. Let's look at the 0 and 2 pi. Tangent would be sine over cosine, so it would be 0 over 1 or negative 1. Well, that would equal 0. So tangent is 0 here, but it's 1 at all the pi over 4's or negative 1. Here you have the square root of 2 over 2, square root of 2 over 2, which would give you a tangent of 1. Similarly, down here you have negative square root of 2 over 2 over negative square root of 2, so that's also 1. But in quadrants 2 and 4, the tangents would be negative 1, because here the cosine is negative, here the sine is negative. Well, when you draw that, so remember we're going to have zeros at the pi values, so we have 0, it's 0 here, 0 here, 0, 0, but then it was 1 at pi over 4 right here, and it's negative 1 at negative pi over 4 or 7 pi over 4 down here. So the graph is doing this number. Okay? And it does that in each of the periods. So you can graph the 0, you can plot the 0, and you can plot the point right there where it is at pi over 4 and at 1. Let's talk about some of these dynamics here then. So you know that your asymptotes are at any multiple of pi over 2 when you keep adding pi. So we're going to come over here and we're going to say that the asymptotes are vertical lines, x equals pi over 2 plus a multiple of pi, and all the pi over 2's. Now let's also look at the domain and the range. The range then is any value, right? The range is simply negative infinity to infinity, but the domain would be anywhere except at those asymptotes. So we're going to say the domain is all reals except it cannot equal the asymptotes. My x-intercepts, okay, my x-intercepts are at multiples of pi. My y-intercept is there at the origin. End behavior, let's look at the end behavior. It doesn't have any. It oscillates between down, up, down, up, down, up. So the end behavior doesn't exist, and the whole graph oscillates between negative infinity and infinity. Okay? Symmetry, this has origin symmetry, so it's odd, and it is infinitely discontinuous. At the asymptotes. So let's say at the asymptotes. It's infinitely discontinuous. Now let's go to cotangent. When you have the cotangent graph, let's go back to our unit circle. Cotangent is equal to cosine over sine. So here, where sine is 0, it's undefined. Well, sine is 0 here. So our cotangent here is undefined. And likewise at pi, cotangent is undefined. But here at the 3 pi over 2 or pi over 2, here this would be 0 over 1, which would equal 0, so the cotangent is 0. And here you would have it over negative 1, so this also would be negative, or 0, because you'd have 0 over negative 1. Now, at all of the pi over 4s, you're still going to have the same value. So here, cotangent is also 1. And across the circle, this would also have a cotangent of 1. Here, your cotangents are negative 1. So those do not change. You change the value, the order, the fraction changes, but the value won't change. Now put that on the graph. Remember, it's undefined here at multiples of pi. So when you go to your graph, now our asymptotes are here, 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 any multiple of pi. And we have our zeros, it equals 0 at the pi over 2s. Now you still have, here at pi over 4, it's still 1. So at pi over 4, we're still 1. And at 3 pi over 4, 5 pi over 4, it is still 1, negative 1. Let me get that right. At 3 pi over 4, I was right the first time. Down here, it's negative 1. Look what happens. It's flipping the other direction. Okay? It's going that direction. Here, here, comes down, does this little snake thing. Okay, that's 3 periods of the cotangent. Let's analyze that a little bit. Here, your asymptotes are now at multiples of pi. So the asymptotes are still vertical lines of x equal some multiple of pi. Our range is still negative infinity to infinity. Our domain is now every x except where our asymptotes are, which are multiples of pi. Our x-intercepts, okay, where it intercepts the x-axis, are now multiples of pi over 2. Right? So they're at pi over 2 plus some multiple. Okay? Y-intercepts, you don't have any. None. Symmetry, you are still symmetrical to the origin. Still odd. Continuity, it's still infinitely discontinuous. At the asymptotes. The end behavior still doesn't exist. And it still oscillates between negative infinity to positive infinity. Now your equations, I only put tangent here, but I could have very easily put cotangent here. This is the exact same parts of the equations that you have seen before when we did logarithms, exponents, any of those parent functions. We break it into little pieces. You do have a couple different things that are at play here. You have what's called a period. Now, we had the periods with the sine and the cosine. You look up here, your periods are between these asymptotes. So here, to get the period, it's only a distance of pi. Look, if I go pi over 2 to negative pi over 2, that's just pi. Here I go 0 to pi. So to get the period, you take pi and divide it by the b value. So that is real important. That is different than the sine and cosine, and it'll be different than the cosecant and the secant, actually, too. Another thing you'll look for that you're used to, it's just something I may ask you, is for the vertical shift, where it goes up and down, and the phase shift, that's this part here, where you're playing with, is it going to the left, is it going to the right? You're going to look at that bx plus c value. And then you also are going to sometimes need to give me the equations of the asymptotes. Now, I wrote this out for you. Your book makes a point of having these equations and memorize them. I don't. I think if you know your unit circle and your graph, then you can identify where the asymptotes are for each period. Here, the A still expands it vertically. Here, this value, the B, let me draw that arrow, the B is still going to express or compress it horizontally. But something really important that you need to take away from this is there is not an amplitude. Even though it has an A, if you look at your graph, there is no amplitude. It does not stop at one point up here on the graph. It keeps going and going and going. That's why the range is negative infinity to infinity. So it's really important that you remember there is no amplitude for tangent, and there is no amplitude for cotangent either. All right, let's look at secant and cosecant. When you do cosecant and secant, you need to remember that they are the reciprocal functions for sine and cosine. So let's start with cosecant. Cosecant first has 1 over sine. So let's look at those values. Here, if sine is 0 or is 1 and negative 1, then my cosecant is 1 over 1 or 1 over negative 1. But here, when you're at the pi's, you have 1 over 0 if the sine value is 0. So here we are undefined. Here we are undefined. All right? When you have the cosecant value at the pi over 4s, that would be 1 over the square root of 2 over 2, which would invert that. So it would be 2 over the square root of 2, which is about 1.4. So here you have positive sine values of 1.4. Down here you would have negative values of 1.4. I'd like you to remember that when we're going to go back to our graph. Now, when you look at the graph, that since this is 1 over sine, I'd like to just basically graph very lightly. I'm going to graph the sine function. Remember, the sine function has one peak. If you notice, I'm just kind of dotting this. Has one valley. Has valley, has a peak. So I just sketched out 2 periods of the sine graph. But remember from our circle that cosecant, 1 over sine, is undefined at the pi's. There are your asymptotes. So here I have an asymptote at these pi values. Okay, that's my signal to start the next video, I will be right back.